All right, you all are now recording, so your personal lives are to be forever remembered. Okay, so I know we kind of tapped it in, but I feel like the more times, ladies and gentlemen, you say these formulas out loud, the more likely you are to remember them. So by seeing them, writing them, saying them, smelling, but no, hearing them, the more senses you can involve, the more likely you are to remember them. Which is why they say, like, if you chew gum, then you do better on tests. That's only true if you chew gum while you study and then you chew gum while you take the test. Like, that scent and that taste will trigger memories. If you, like, smell certain... There's sometimes that I smell things and I remember, like, different times, like, oh, that reminds me of, like, this time. Anyway, I don't know why. But the more senses you have in learning, the more likely you are to remember. So, if you say them, hopefully you'll remember them. Yes, I don't know, but that's what I've been taught. So, volume of a prism. Say it, what is it? Just a generic formula. Base area times height. Now, a cylinder is very similar to a prism. It's technically not one, but it has the same properties. I can be a little bit more specific because the cylinder always has what is the base shape? A circle, and the area of the circle, pi r squared. And then you have to multiply it by 8. So these two, very similar. Pyramids and cones are also very similar because they come up to a point. The pyramid is a lot like the prism, except what? It needs the 1/3, and why does it need the 1/3? Good. Now the cone, we can make a little bit more specific. Does it need the 1/3? Yes, because it comes to the point. And then instead of b, we write pi r squared times h. This is the only one that is not fair game on the quiz tomorrow. It will be written on the test for you. It is not in the math course to memorize this one, but I'm hoping that you've used it so many times you'll have it memorized. But it will be written on the test for you. The volume of a sphere is 4/3 pi r cubed. Okay. Now, I'll be honest. There's 11 units. If I were to rank this from 1 to 11 on how favorite this is, it's probably 11. There's nothing super exciting about it. You just plug in numbers and put in your calculator, and I end up waiting. Always give me decimal. Okay, so if there's not a lot of enthusiasm from your fearless leader, that's because this is not super exciting stuff. I could do trig all day and I get excited about it. Volume? Yeah, whatever. Okay, so part A. Again, I don't expect this on the homework, but on the notes we're going to do it just because I want you to say it. What is the formula for a cylinder? Now the fact that it's a right cylinder means that this cylinder is standing straight up, it's not leaning. The formula wouldn't matter. What's the volume of the cylinder? Does it need the 1/3? Does it need the 1/3? The cylinder. No. So, circle. Time. Good. What do we know here? Radius, 24. 0.1 squared times the height. And then everybody plugs in. So whoever gets first can shout it out. You don't all have to wait. But not everybody at the same time, because then I can't hear you. And then you have to put the dimensions, so centimeters cubed. If I were taking the test, and this was worth 4 points, this part of the answer would be worth one of those 4. You have to have the units on there. Why is the units cubed? Because volume is a 3-dimensional measurement. Yes? In the problem, then you don't have to worry about it. No. Nope. If the problem doesn't tell you what the measurement is, don't worry about it.
Pardon the interruption. Can I get Elise Christensen to attendance for checkout?
Sure can.
Thank you.
Thanks. Okay, Okay, part B, a cone. What's the formula for a cone? Does it need 1/3? 1/3. What's the area of the base? Pi r squared times the height. So volume equals 1/3 pi r squared times the height. Plug that into your calculator. I think it's 94 point something. 94.24 centimeters cubed. Never round to never round to the whole number. Always give me at least one decimal place. Unless you're doing like percentages or money. If you're doing percent or money, round to 2 decimal places. Before 256. Okay, part C. There's several typos on this one. You can make fun of me and over it. Find the volume of king test pyramid. So do we use 1/3? Do we go to shape of the pyramid? No, but we're going to have to make an assumption here. The base has a width of 300 and a length of 40 or 400. What do we guess that it is? Probably a rectangle. So area of a rectangle, length times width times the height. Again, there's 3 parts. The 1/3, the length, the width, and then the height. Volume equals 1/3 times the length times the width times the height. No, I don't care if there's pictures. Yes. Possibly. Yep. So if this was 300 and this was 300, we would have known it was a square pyramid because the base of the width. So then 300, 200. King Tut, you lucky man. Okay, moving on. Part D and part E. Please do them on your own. Please. Really easy to plug this into your calculator and not put anything on the paper, right? On the test, you have to put something on the paper because I have to see if you got it wrong, what you got wrong. So let's just make the understanding now that if you say the answer is 15 something something without writing something down on the test, you'll be marked wrong automatically. You make your answer right. I need something. It's not a lot. It's great to write down. You don't have to write the formula. I'm going to right now simply so that you can help you memorize it. But on the test, just right, you're plugging into the calculator. So on this one, it's a right circular cylinder. This word, I guess, is not really necessary, right? Does it need the 1/3? No. Pi r. So it's r squared 8. Pi. What's the radius in this case? It's 6 squared times the height. Why is it 6? Because the diameter is 12. You have to half the diameter. And then it's 1590, 4 feet cubed. Okay, and the next of a sphere? 1/7. R cubed. The radius is 4, so 4/3 pi 4 cubed. Then 58.1 is in the next round. Is that right? Okay, questions on that? I flew through it. I hope I did it better than you. Are you guys ready? This is the test that's going to boost everybody, right? I think you're good. Okay, part F, G, and H are slightly different. Where I'm not looking for the volume, this time I'm looking for the height or the radius or something else. The process, however, is the same. So let's start by putting the formulas on the paper. The first one is a cone. Is the cone used 1/3? Yeah. Because it has no point. And then the cone's base shape is what? Circle. So the formula is pi r squared, and then you need so what do we know? The volume is 65. Where does the 65 go in my formula? Where does it is? Volume is 65. We put it in the 65 volume condition. Now 1/3 pi, do we know radius? Radius squared, h. This case, we're trying to solve for h. And start. Good idea. Good idea. I would probably make it a little bit easier on yourself. This right here is just a number, right? I'd probably just calculate that. Now, if you're going to be rounding inside of your calculation, I would round to 4 decimal places. The more decimal places you have, the more accurate your answer is. So let's get a decimal here that gives me 4 places. 9.4. You just said 9.4, your answer is going to be more off than maybe it should. Now these are connected by a multiply. So how do you cancel that multiply? You just divide it. So divide by 9.4247. 9.4247. Those cancel. And h equals what? 6.3 again? 9? Final answers, I would be okay with just 1 decimal place. Not 0. 1's fine, you don't need 4. 6.9 inches cubed. It's depending on what kind of measurement this is. Oh, not cubed. But good question then. This right here is just the length, right? Because it's height. So it should just be inches. My mistake. Thank you. Yes, sir. Volume cubed. Round would be better. Was this one rounded correctly then? Or was it just chunked? It's 6.9 what? Oh, then we're fine. 6.9, yeah. Okay, part G. The volume of a spherical fishbowl. Stop. What's the volume of a sphere? Okay, I'm going to really quick. Question what you know. Alright, so what do we know? We know the volume, which is what? 523.599 equals 4/3 pi r cubed. We're trying to solve for r, right? What do you suppose we do first? Let's multiply what we can. In this case, it's a little bit smaller, just 4/3 pi. So how do you plug in 4/3 on your calculator? You know? It's 4 divided by 3. Yeah. So then we should have 523.599 equals, can you pull this number, please? 4.1888. Okay, our cube. These are connected by a multiply, so what do we do? Divide. So r cubed equals, now this one should be so close to 125 that we can just call it 125, is it? 125. Now what does this mean? It means something times something times something equals 125. What is that something? Well, what times what equals 125? It's a perfect cube. So on your calculators, try 1 times 1 times 1. Don't try that one. Try 2 times 2 times 2. Try 3 times, what is it? 5? 5 times 5 times 5. Does that work? So what is your radius? 5. Which means what's your diameter? How did you get it? And it's going to be 5 inches, 10 inches. Is it the length? Okay, we're on our last one, and then you'll be able to work on your homework for about 15 minutes, and then we'll come back and do scale factor. The volume of a cylinder is 189 pi centimeters cubed. If the radius of the cylinder is 3, find the height of the cylinder. Go ahead and try that one on your own. I get honorary, and nobody wants an honorary teacher. Okay, let's finish this one off. The volume of the cylinder is 189 pi. First of all, cylinder is what? Starting by the
189.
Having r squared feet, right? Hold on, pause. 189 pi equals pi. Do we know r? R squared h. So what do you do first? This right here is a what? It's a number, right? So give that to a decimal place. What is it? Okay, and then you divided both sides by 28.2743. Right? And what does it each equal? And centimeters? It's not 6. Oh, it's actually probably so close to a whole number that it should be a whole number. 21? 189 is times that by 5 instead. Oh, no, I meant like your final answer doesn't have to have the pi. Perfect. Okay, you have 15 minutes to work on your homework packet. We already talked about skill factor this year. Hold on. Unit 2. And when we talked skill factor before, we did a lot on the coordinate plane where we dilated points and made them bigger and smaller. You remember that? Yeah. Now we're going to talk about how the skill factor affects the length of the segment, which is this, by the way, a one-dimensional, right? This is a one-dimensional figure. We're going to talk about how skill factor affects the length, how it affects the area, how it affects the volume. So on this one, right here the length is 2, right? If I take that length of 2 and increase it by a factor, this right here, there's a keyword that's indicated as the multiplier. So with a scale factor of 3, my new length, which when we did dilation before, we did a little climb there, so I'm going to do that here. My new length will be what? 6. Okay. This one, the length is 5, but if I use my multiplier, my new length will be 15. one will be what? So I can make kind of a general statement that says if I am increasing a one-dimensional figure, I'm going to multiply by my scale factor to the, okay, if I have a rod that's 2 and I enlarge, or when you go to explanation, it'd be like a balloon, like the balloon animals, right? They start this big and we're enlarging them and now they're this big. And then the length, yes. In a minute. So I'll let you be the concluding statement, but I want to throw some numbers first. Okay, now let's look at our two-dimensional figures. First, before we start, let's find area of all of these. So area of this is 4, because this is squared. Area of this guy is 49. Okay, and the area of this guy would be 49. Now, if I were to increase the side length, you have to increase both side lengths by a factor of 3 again. This becomes a 6, this becomes a 6. What is the new area? 36. What's the new area here? This is now a 16, this is a 16, so we've increased it by a factor of 3. New area is 225. And if we increase this by a factor of 3, my new area is 441. Now, when I was talking about just a simple length, the length is 3 times bigger. If I'm talking about the area, and the scale factor is 3, is it still 3 times bigger? Is 36 3 times bigger than 4? No. How many times bigger is it? What times 4 is 36? 9 times bigger, right? How many times bigger is the 225 than the 25? Well, we can calculate at this point. How many times bigger is the 225 than the 25? This is 9 times bigger. And what about this one? Stay with me, please. Confirm that it's 9 times bigger still? It is? Okay. So I want you to think about it for just a minute. Don't say anything out loud because I promised Marcus the walkthrough. But I want you to think of how this 9, with all of those 9s, the fact that it's two-dimensional and the multiplier was, the scale factor is 3, how do those have in common? What's the commonality? What's the correlation? Why is this 9 times bigger when the scale factor is 3? Marcus, do you have any idea?
I'm going to guess that because it's two-dimensional, you have to square the k number, and then that would correspond to what you have to use.
You multiply by k squared when the measurement you're taking is a square measurement. Because it's a two-dimensional figure, you have to multiply it by k squared. And the reason is, I'm increasing one dimension and two dimension when I multiply those, it's a square again. So let's look at the very, very last page of your notes. Very good. So this is the very last page. Let's practice an example of this. So it's going to be a little bit of writing. I'm sorry. The blank page, yep. If the area of the rectangle is 12 inches squared and each side of the rectangle is increased by a factor of 4. What is the area of the new rectangle? That's rectangle is 12 inches squared, and each side of the rectangle is increased by a factor of 4. What is the area of this rectangle? Let's see if we can figure that out and then we'll move on. Ooh, 60, 60, 60. So in this case, what's the scale factor? Scale factor is 4 in this case. So the area multiplier is not going to be 4. What will it be? 4 squared, because the dimension of an area is 2. Is that okay? So the area multiplier in this problem would be 16. So if I want to find the new area, what do I do? You take the original area, which is 12, multiply it by the area multiplier.
Please coordinate health attendants for pickup, please.
This one, multiply those two, what do we get? 192. Inches, now what unit is it? Inches squared, inches cubed, inches squared. Why? There's a square calculation here. It's a two-dimensional measurement. Okay? Does that make sense? Sarah? 12 is the original area, yeah? Yes, right. On the 4 or the square? Because it's the area. And the area is a two-dimensional, so it's squared. Yep. What? If it was a circle, it doesn't matter. If it's a two-dimensional, if it's talking area, and that's a two-dimensional measurement, then my multiplier will be squared, regardless of the shape. Does that make sense? It doesn't matter the shape, as long as the measurement is a two-dimensional measurement, the multiplier will be squared. So let's move on and think about what we would do if it was a volume. And I think for lots of time, let's skip all of this and go down to the example. Again, the fact that it's a pyramid doesn't matter. The pyramid has a volume of 12 miles cubed, and each side length of the pyramid has been increased by a factor of 3. So that's the scale factor, right? If I want to find the volume multiplier, any ideas what I will do? What should I do? Everett. Yeah. So the volume multiplier is the scale factor, and volume is a three-dimensional measurement. So my volume multiplier will be 3 cubed, which is 27. So to find the new volume, I take the original volume, which is 12, multiply it by the volume multiplier, and what do I get? 3.4 still miles cubed. So depending on the dimension of whatever you're measuring and increasing is what this number looks like. So let's do another one. I think we're out of time, so we need to quickly recap. Just watch that right down. On this one, a sphere has a volume of 4.19, and the radius was enlarged by a factor of what? Don't put stuff away yet. You don't, please. Because then I have to wait for you guys to stuff when you're not paying attention and waste time. Okay, so what's my volume multiplier? So what's the scale factor? 5. And what's the dimension of the 3, right? So my volume multiplier is what? That's cubed is 125. So if I have an original volume of 419, and I want to find a new volume, what do I multiply 419 by? 125. And I get something 500. Okay, so very quick. Next time, what to do? Everything. What do you have at the beginning of class? A quiz. If you are late, do you get to take the quiz? No. If you are before we test. Thanks for watching. Peace out.